Alright, hello. In this video, I'm just going to be covering some general review questions, kind of some stuff that we didn't get to early in the week, getting ready for the semester 2 final. Okay, so the first thing is solving log ones, and the trick on these is you've got to switch form. So this one starts as a log, so we're going to switch it to exponential form to solve it. And the key is you got to make it look like this exactly first. So the problem on this one is we got this times 4. Okay, so I'd encourage you to pause the video and try everything you can on this before watching the solution. And the key is you got to deal with that 4 first. Right, so the trick is you could move the 4 up and make it an exponent. That wouldn't be wrong, but it's a little bit easier when it's solving. You can just divide everything by 4, and then that'll clean up the question a little bit. All right, that'll just give you 2 on this side. Okay, and now that it looks exactly like this, now I'm going to switch forms. And if there's no base, right, we're missing the little base, you just add it in, it's just a 10. So now when we switch forms, the base is 10. Log means find exponent, so this thing's my exponent. And then it equals 3x. And now we're pretty much done, right? That's called switch forms. And once you get there, you're good, because now you just have 100 equals 3x. And then just divide everything by 3. And you get like about 33.3 as your answer. Okay, next up, another solve one. The difference here is this one starts exponential, and you've got to switch it to log. So again, I encourage you to pause the video and try it before watching the solution. All right, so this one is already set up in base exponent form, so we just got to switch it right away. And a lot of times I see people like divide by 4 or something here, but if the x is up as an exponent, you're going to switch it to log. All right, so what that would be is log, the base is 4. Log means find exponent, so it goes on the other side, which is what we want, right? Now it's down out of an exponent. All right, and then the value 256 goes there. Right, and we can see this is helpful because now we just, as long as we can do the left-hand side, we'll just divide by 2 and we're done. Okay, so to evaluate this left-hand side now, you got to use your calculator, and there's 2 ways to do it. You can just do log of 256 divided by log of 4. Okay, so basically your calculator is just base 10 log. So if this is base 4, then you've got to do log divided by log. Okay, and then the other thing is if you happen to have one of these more advanced calculators, you can hit math and go up, 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 and there's a log base option. And then that's pretty slick because then you can do non-base 10 logs. Right, so either way you should get 4. Okay, so now we got 4 equals 2x. Now just divide by 2 and boom, we got our answer of 2. Okay. So one more thing from chapter 7 that we really didn't get to much in class was the 2 interest formulas. Okay, so I think these are on the final in some form or another. So I would just have you read the question and try it. You don't have to memorize the formulas, but you do have to know how to use them. So go ahead and pause the video, give this a shot. Okay, so it's the same problem. The only difference is we're going to use this formula on letter A, and then this other one is the continuous. So if the question says continuous, then you use the PERT formula. So on letter A, we're just going to do 50,000 for A, and then the rate as a decimal, make sure you move this over twice and add a 0. So it's 0.055, and then the time is just 4 years. Okay, and then it's just a matter of typing all that in your calculator to get the answer. So here's what it looks like in the calculator, 50,000, 1.055. I'm actually adding those together. Right, add the 1 and the 0.055, and then do the little hat thing, 4th power, blah, 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 and we get 61,941. Okay, and then we'll find that the continuous should be a little bit better. So this is the same thing, except now use PERT. And P just stands for the starting amount, kind of like little a in the other formula. Remember, E is like 2.7. And then we do the rate as a decimal times the time. Okay, and now it's just crunch. And the key on the calculator you need is that e to the x. So for the continuous, I'm going to do 50,000 and then this e to the x key right here. You got to hit the second button. And then 0.055 times 4. Okay, and so that one's a little bit better. If I round it to the nearest dollar, it'd be 62,304. So 62,304. So the continuous interest is a little bit better than the annual interest. Okay, next up is the series sequence stuff. And again, I'm just trying to hit some stuff that we didn't get to fully cover when we did the Chapter 9 review previously. Okay, so first ones are just, are they geometric, yes or no? And if they are, find the ratio. And the ratio is the number you're multiplying by, called R. So pause the video, gives us a shot. Okay, so the first one is yes. And it's kind of like timesing by 4, except it's switching negative positive. So it just means we're timesing by negative 4. So R is negative 4. What am I doing? Not negative 2. R is negative 4. Okay, second one is not geometric. It looks like it is. It's kind of dividing by 2, but then it switches to timesing by 2, so that one does not qualify as geometric. Okay, find the sum of the first 10 terms. This is really figuring out the right sum formula. So the sum formulas are on the bottom down here, so see if you can find the right sum formula. Okay, so this one is geometric because we're timesing by 2, and it's finite. It looks like it's infinite, but because it says 10 terms, it's finite. So we're going to use the geometric finite formula, which says the sum is the first term, and then 1 minus r to the n over 1 minus r. Sorry, this r looks kind of wonky there. All right, but a1 is just the 1. R is just 2 because we're timesing by 2. N is 10 because there's 10 terms in the pattern. So there's our setup. And then the way, I don't like to do this all in the calculator because you need a lot of parentheses. So I normally just do the denominator on its own and then do the numerator on the calculator. So I'm going to do 1 and then in parentheses 1 minus 2 hat thing 10. Okay, and then I get that answer, but then it's just going to divide by negative 1. So we get negative 1023. Divide by negative 1, and that gives us 1,023. Okay, which makes sense. If we got a negative sum here, that would have been not great. But once we divide by negative 1, we get a sum that makes sense. Okay, so this would be an infinite series, and you have to say, does it diverge or converge? And then if it's possible, find the sum. Okay, so the trick here is converging. You're getting closer to 0. I always think of converging like if you converge on a cupcake, that means everyone gets really close to the cupcake. So we're converging towards 0. So this one is converging. Converging. All right, which means it'll have a sum. And to do the sum formula for a infinite geometric is that, where a1 is just the 20. And then the r in this case is kind of tricky because this pattern is dividing by 2, but r is the multiply number. So r here is 1/2. Okay, so in our setup, we got to do 1 minus 1/2. And then if you're using a calculator, you got to be really careful. I honestly would just do 1 minus 0.5 on the bottom to give you 0.5. Like 1 take away 1/2 is 1/2. And then divide these and you get 40. Okay, and that sum should make sense. Like if you look at these, add all these up, that's like 37.5 plus some extra stuff. So the fact we got 40 as a sum is probably a pretty reasonable answer. Okay, we're jumping all over the place. We're on chapter 11 now. So this was that probability stuff. Remember, probability is just the favorable over the total. All right, so in this question, the total is just add them all up. So we just got to add 12 plus 8 is 20, 21, 30. So we have 30 total students. And then the top is just anyone that is cool or a sophomore. So I kind of go through and say, like, these ones count because they're cool. These ones don't count. These ones count because they're cool, and sophomores, actually. And then these ones count because they're sophomores. They're uncool sophomores, so they count because it can be cool or a sophomore. So out of all of them, if you add all those up, that's 22. Right, so our chances of being cool or a sophomore is 22 out of 30 if you draw one at random. Okay, and then always reduce, because on a multiple choice test it'll be reduced like that. Okay, next up is conditional probability. And so you see if you can do probability that someone went to prom given that they're a junior. So I'll pause the video and have you give it a shot. Okay, so when it says given that they're a junior, that means we only care about juniors. Okay, so I'm going to highlight them right there, and that's our denominator. That's 450, because when it says given that they're a junior means you look only at the juniors. Okay, and then out of those juniors, how many went to prom? So out of these 450, 250 went to prom. All right, and then you can obviously reduce it a little bit. That part I don't worry too much about. Divide by 5, you get 5/9 chance. Okay, so whatever is here is your denominator on a given that. So if I want to do another one here, maybe I'll do probability you are a junior given that you went to prom. Okay, so now what we would look at is when it says given that you went to prom, we're going to look at all the prom people. Okay, so that would be these people right here. Okay, and that's our denominator. So our denominator is 300 prom people. And out of those prom people, how many are juniors? So out of these 300, 250 are juniors. Okay, so the probability you're a junior given that you went to prom is 250 out of 300. And again, you clean that up or whatever. I think it would be like 5/6, I think is what that cleans up to. Okay, so last part here is chapter 8. And this was about rational expressions, which is what you're looking at right here. And when it says simplify, you just got to factor and cancel stuff, right? So basically, I guess technically, I don't know why I put simplify. Technically, this is a multiply because we got to multiply symbol between them. But it's basically a factor and cancel. It's like one giant simplify. Okay, so again, pause the video, give it a shot. Okay, so factored apart, b squared is b times b. And then this denominator is always tricky, but it just has a GCF. So pull up b to the front. And then up top, we're going to do two little factors. They're both going to be negative. They multiply to positive 20, but add to negative 9. So it'll be 4 and 5. Okay, and I actually do my restrictions right now. So restrictions are anytime the denominator is 0. So we're going to have restrictions of 5, 4, and 0. Because you have a times b, that leads to a 0 restriction. Okay, and then now is the fun part. You just get to cancel out. So we have matching b minus 5s. We have matching b minus 4s. And then this times b will cancel with that times b. Okay, so what's left up top is just b, and on the bottom is really just 1. So all that just cleans up to be b. Okay, divide one, right? It's going to be real similar to the multiply with one different step. Okay, so the main difference here is you have to do keep, switch, flip. So before you do much else, turn it into a multiply by the reciprocal. Why am I doing x? Sorry. Okay, so keep, switch, flip. Keep the first one, switch it to multiply and flip. And then factor up top here. So this is going to factor to k plus 3 and k plus 5. And again, before I cancel, I'm going to do my restrictions, which on a division 1 is the denominator like normal, but then also the numerator of the back. Okay, so that's a little weird because normally it's just the denominator. So here it would be, let's see, negative 5, 4, and then negative 3, and then negative 5 again, but I already listed it, so I don't need to list it. Okay, so the restrictions are weird. You got to look on those three parts here. Okay, and now it's cancel time. So we have matching k plus 5s, and then I think that might be it. This one's kind of lame. It doesn't clean up very much. All right, so the top, I guess, is just k plus 2 times k plus 3. And the bottom is just k minus 4 is left. I don't know why I wrote x. I'm so used to writing x. That's k minus 4. Okay, and that's our cleaned up version after we divide.